Okay, so welcome, and today we're going to start talking about inverse trigonometric functions now. So before we get into graphing and all the other things that we're probably going to talk about later, we have to understand what it means for an inverse function. Okay, so as we know, inverse functions are functions that undo what functions do. Okay, so in other words, if I have, for example, a function that has this, right? Excuse me. E to the x, right? Well, as we know, then the inverse function of this is going to be the function g of x equals the natural log of x. Because what happens? This function undoes this function. And so these are inverse functions of each other. Which means if I compose these, I'm just going to get x out. Because if I exponentiate x and then take the natural log of x, I'm just going to get right back to x. Okay? So another way to think about it is, if I have from the domain the range, right? A function takes a value from the domain and maps it to the range. Whereas the inverse function takes that value, right? Takes that value, y1, x1, where the inverse function maps it right back to x1. So that would be the inverse function, f inverse of x. Okay, so what about inverse functions for sine, cosine, and tangent? Well, same thing, right? So we know, for example, sine of pi over 6 is equal to a half. Cosine of pi is what? -1. Tangent of pi over 4 is +1. Okay? And so, what do the inverses mean? Well, think about this. So, what we say is sine inverse, right? So, if sine of an angle is giving me this ratio, right, gives me a number, then if I do the inverse, which means if I take the inverse of 1/2, right? If I take the inverse of 1/2, which means, so what I'm looking for is an angle, because in a lot of situations, we might want to know, hey, what angle do I need to have in order to have this particular result, okay? Or what, I'm looking for the angle, right? Here, I'm given the angle, and I got the ratio, right? I know that sine of this angle gives me this, okay, this measurement. But what if I don't know this angle, but I know the sides and I know I can put the ratio together, okay? And I have this ratio and I want to know, okay, what angle will give me that ratio of lengths, for example? Well, then that's where the inverse function comes in, because the inverse function gives me an angle. That's what happens. So if I say sine inverse of 1/2, that's going to equal pi over 6 or some multiple, right? Because again, if I add pi or subtract pi to this, I will get, or excuse me, 2 pi. If I subtract 2 pi or subtract 2 pi, I'm going to get the same answer. So this would be the smallest angle, right? If I take cosine inverse of -1, that's going to give me pi. Or in plus or minus some multiple of 2 pi. And then tangent inverse of 1 is going to give me pi over 4. Plus or minus some multiple of 2 pi, or excuse me, a pi. And by the way, we call these inverse functions. So the jargon or the way we call these is either inverse sine, inverse cosine, or inverse tangent, or you'll hear us say arctangent, or actually arcsine, arc cosine, and arc tangent. Okay, so they mean the same thing. Okay, on your calculator it'll look like this. Okay, or it may say arctangent. Okay, arcsine, and so on. They mean the same thing. Okay, so that's what we mean by being an inverse trigonometric function. So now, a couple of things we need to discuss. Because one of the things that in order to be an inverse, to have an inverse function is the function needs to be one-to-one. And as we know, sine and cosine are not one-to-one functions. In fact, none of these are one-to-one functions. Okay? So how can we be talking about inverse sine, cosine, and tangent if these are not one-to-one functions? Well, what we need to do is we need to restrict the domain. So when we're talking about sine, and again, the way we restrict the domain is a little bit arbitrary, but there's a reason, there's important characteristics of why we restrict the domain this way. But we usually want to include 0. Okay, so for example, in order for this to be a one-to-one function, we're going to restrict the domain of sine is going to be restricted to pi over 2 negative pi over 2 to pi over 2. Okay, or no, I'm sorry, that's not true. This is going to be 0 to 0 to pi. Or hold on a second. No, I was right the first time. I'm sorry. I'm thinking in my head what it looks like. So this is going to be negative pi over 2 to positive pi over 2. Okay, because remember, again, it's got to be one-to-one, right? Which means it's got to pass the horizontal line test and the vertical line test if you, as far as graphically. So with the sine, it looks like this, right? So it's, from negative 2 to negative pi over 2 to positive pi over 2, it's going to look like that. Okay, so, okay. For cosine, we're going to want 0 to pi. Okay. And then for tangent, it's going to be negative pi over 2 to pi over 2, but not including the endpoints, because again, the way we're going to do this one is between asymptotes. Okay, so it's natural to just do the interval between the first two asymptotes, and of course this also includes 0 in the domain. So now if we restrict the domain of these intervals for their respective functions, trig functions, then we know that these are one-to-one functions over these particular domains, which means now we can start talking about the inverse functions. Okay, now the other thing too is, if now that we established when a function is one-to-one and when an inverse will exist, and that these inverses do exist if we're restricting to these intervals, the other thing that we need to talk about is the range and domain. So again, recall that if you have a one-to-one function and you're looking at the function and its inverse, the domain and range of the function is switched when you are talking about the inverse function. So for example, this is the domain for the sine function, but the sine function the range of the sine function, let me put it in another color. So the range, though, over this interval is -1 to +1. And the range for cosine from 0 to pi is also -1 to 1, inclusive. And the range for the tangent function from -pi/2 to +pi/2 is from -infinity to +infinity. So that means when we talk about the inverse functions, they're switched. So the domain for inverse sine is going to be -1 to 1. The domain of inverse cosine is going to be -1 to 1. And the domain of tangent is going to be from -infinity to +infinity. And then the domain of inverse sine is going to be, or excuse me, the range of inverse sine is going to be the domain of sine. So that means this is going to be now -pi/2 to +pi/2. Oops. And the range of inverse cosine is going to be the domain of cosine, which is 0 to pi, inclusive. And then the range of inverse tangent is going to be the domain of tangent, so that's going to be from -pi/2 to pi/2. Okay, so some more characteristics that we want to make sure we understand as we go into and start talking about inverse functions for trigonometric functions. Now, in this case, okay, so what does this mean? So, if this is all satisfied, right, we restrict the domain, right? And if we restrict the domain to these intervals, right, talking about this one, and this one, then we know that these are one-to-one functions and we can talk about the inverses. So for each one of these, then what we can say is that if we have y equals sine of x, then that means that the inverse function, excuse me, so if we take the inverse of both sides, right? So let's take inverse sine of y equals inverse sine of sine x. Now remember what happens when you compose two inverse functions. What happens? They cancel each other out. They undo each other. So the sine of x, if I take the inverse sine of the sine of x, then what do I get? I get x. So if y equals sine of x, then inverse sine of y equals x. And similarly, if I talk about cosine, right? So if y equals cosine of x, then that also tells me that cosine inverse of y equals x over this domain. And then finally tangent, right? So if y equals tangent of x over this domain, then I can also say that tangent then inverse of y must equal x. And those three equalities hold. And that's it. See you next time.